Okay, this is question 18 from chapter 7 on page 196 of your textbook. Um, it says we want to predict price from capacity. And so we have data on hard drives. We have the capacity in terabytes. That's the explanatory variable. Price is the response variable. And we know that because it says predict the price. And whatever you want to predict, that's your explanatory variable. All right, now, in previous videos, I showed you how you can get the equation of the least squares regression line using StatCrunch or spreadsheet. On some homework questions, though, they just tell you the equation, but they give it to you in a rather cryptic method. So down here, look at these numbers. We have it says variable and it says coefficient. A coefficient just means the number in front of a variable. We have the variable capacity right there, which is the x coordinate. It's the explanatory variable. It says 142.177. From the previous video, we know that is the slope right there. And so whenever you have the explanatory variable and the coefficient of it, that's your slope. In other questions, like for example, like number 17, it says height, it says coefficient, and so in 0.96, that would be your slope on that one. And then where it says constant means it's not a variable, it's just a number without a variable next to it, and so that would be your intercept, which is negative 296. I don't know why they just don't say intercept and slope. That would make more sense. But anyways, that's how they do it. And so that would tell you that your equation would be the quote unquote the constant negative 296.3 plus, and then where it says coefficient is 142.2. That's your slope times x. All right, and actually that's the answer to part A of this question is what's the equation. Okay, now there's more questions on the next page. Part A. Okay, write the equation. Okay, did that. B, interpret the slope. All right, so the slope in this case, this is part B. It means, so first of all, it's 142.2. And so slope is always, think of it as y per x. That's the way to think about slope. And so in this case, x is terabytes of memory. Y is price. I'll just put a dollar sign. And so it would be dollars per terabyte is slope. And so in other words, to explain this in a sentence, you would say for each 1 terabyte increase, the price increases by $142.20, rounded off. Okay, now does that even make sense? Let's go back to our raw data here for a minute. So does the price really go up by $142 for every terabyte? That seems pricey, but this is a couple years old now, this data up here. But you can see that, for example, you go from 3 terabytes to 4 terabytes, the price went up only $40. But then you go from like 4 terabytes to 6 terabytes, the price goes up like almost $300. And so you could say that on average, $100-something per terabyte seems like a reasonable approximation. Okay, so that's it for part B. Let's answer part C now. Part C says, okay, interpret the y-intercept. Is this meaningful? So y-intercept is always, if you look at the graph, you have terabytes is the horizontal axis, you have dollars is the vertical axis, you have your dots, they look like this, and you have your line. So wherever the terabytes equals to 0, wherever that explanatory variable, the x, if you want to call it the x, equals 0, that is your intercept right there. And so in this case, it's the price for 0 terabytes is what the intercept is. And what is that number? It's negative 246.3. Okay, and that would be dollars. So no, that doesn't make any sense. First of all, a 0 terabyte hard drive would be a non-existent hard drive. And you can't have a negative price. It's like they're paying you to take the hard drive. So it does not, in this case, it does not make sense. And often intercepts don't make sense because 0 for something it often doesn't make sense. Okay, part D. Now it says, what would you predict for the price of a 20 terabyte drive? So this is the main reason why people do least squares regression lines is to try to make predictions. And so you have the formula right here. X is the terabyte. So just replace the X with a 20. So you'll have negative 246 points. So Y hat, the predicted price, remember you need the hat to tell you it's the predicted price, is negative 1, what was it again? Negative 246, excuse me. Negative 246.3 plus the slope, which is 142.2, times X, which is 20. And just use your calculator, multiply first. So 142.2. So think of it like this. The price goes up $142.20 per terabyte, and then you times that by the terabytes, 20, which is 2,844. And then you add on the negative, or actually subtract. Adding a negative is the same as subtract. So I'll just press subtract. Minus then 246.3 equals, okay, 2,597. 2,000, what was that again? 597.7. Okay, now I rounded these numbers off. The 0.2 was rounded off. The 0.3 was rounded off. And so when you check your answers, you might get slightly different numbers depending on the rounding. So on the MyLab questions, don't round off to like 1 digit in your equation. Keep like 3 or 4 digits in there just to be safe. All right, but does that answer make sense? For 20 terabytes, would you have to pay $2,000 something? Well, let's go back to our raw data here. And the raw data says for 12 terabytes, it's 1,000. 32 terabytes is 4,000. So 20 is in between 12 and 32, and the price of 2,000 is in between 1 and 4. So it seems like a reasonable prediction. All right, so that's it for part D. Part E. Okay, a 20 terabyte drive on Amazon.com was 2017. According to the model, is that a good buy? How much would you save compared to what you expected to pay? Okay, so 2017.86. Let's go to part E. 1 more time. $2017.86. Okay, so the predicted price, 2,597. Yeah, that's a good deal. So you'd say, yes, it's a good deal. And how much money would you save? So actually, this is a hidden way of asking what's the residual. So we know that the residual is the observed minus, excuse me, I got the hat in the wrong place there. It's the observed minus the predicted. So the actual price is 2017.86 minus what the regression line predicted, 2597.70. Just subtract those on your calculator. And you get 2017.86 minus 2597.70. 0.7 is negative 579. So it's a negative residual because if you imagine that scatter plot, the dots, which would be 2017, is below the line, which would be at 2597. So negative 579.84, and that's dollars. So that's how much money you would save right there, compared to what you would have predicted the price to be. Okay, and then part F. The correlation is very high. Does this mean that the model is accurate? So from an earlier video, we calculated the correlation. Correlation was like 0.98. Also, they tell you that on the previous page, right here, it says R, actually, they don't tell you correlation, but they tell you R squared is 97.5%, which is 0.975 in decimal form. Take the square root and you get your R. But from an earlier video, we knew already it was 0.98. So R is very high. So usually that means a straight line, but not necessarily. You can have a curve that looks kind of straight, even though it's not truly straight. So the answer is not necessarily. And if you look at a scatter plot, and I made a scatter plot earlier, right here on a spreadsheet. If you look at this, it's rising very slowly in the beginning, and then it rises more quickly. So actually, I would say this is more curved than straight. So I would say if you could do a curved regression line, that would actually be a better fit, a better prediction than using a straight line. But all we have now, are, as far as tools go, is straight lines. So I would say not necessarily. The scatter plots shows a curve. Okay, which just goes to show a high correlation does not necessarily mean automatically that your line is going to be straight. You always have to look at the scatter plot to see if it's linear. All right, and part, is there a part G? Let's see here. Okay, what's the value of R squared, and what does it mean? So we're not going to do R what it means, but R squared, well, that's just 0.98 squared, which would be about 0.97 something. If you do that on your calculator, it's like, well, this is rounded off, but it's about 0.96 or 0.97. My calculator says 0.96, but that's because I rounded off. More precise would be 0.97. Okay, that is it for this video.